Hi, welcome to Physics with Ben. Don't forget to subscribe, like, comment, and share this video to those that need it. In today's video, I want us to look at Waec 2024 Physics 3, question number 3, electricity. I have done videos on question number 1, mechanics, and question number 2, optics. So just click in the description box below to find the video links to those videos. Don't forget to share this video to other learners. So without wasting more time, let us go straight to the business of the day. Good. In all my videos on experiments, I have emphasized something I would love to say in this video as well. Mastering the theory of the experiments. When you don't master the theory of the experiment, you go into the experiment confused and you make a lot of errors. You run your experiment with a lot of errors, and you also run your experiment in the darkness. So for you to run your experiment in the light, that is why it is important for you to master the theory of your experiment. I also want to repeat that your experiment is very, very important. This is where the bulk of the marks that would give you that A you are looking for in physics lies. So you must not play with your experiment. Having said that, let us go straight to the business of the day. Now, the experiment this year is on Metre Bridge. So you need to master what Metre Bridge is all about, because examiners would love to ask you questions around this. But before you master Metre Bridge, you have to master Wheastone Bridge, because Metre Bridge is coming from Wheastone Bridge, and you also need to master subtopics like factors that affect the resistance of the wire. In summary, just read about potentiometer, read about Wheastone Bridge, read about the Metre Bridge. All of them have their separate equations, which I will share with us in this video. For now, we are going to start with the Wheastone Bridge. The diagram beside you is the Wheastone Bridge. Now let me derive some of the equations that are around here and also explain to you the working principle of the Wheastone Bridge. How does the Wheastone Bridge work? What is the working principle of the Wheastone Bridge? What is the Wheastone Bridge? The Wheastone Bridge is simply a circuit that consists of 4 resistors arranged, as you can see in the diagram. Now, these resistors are arranged in such a way that you have resistance R1, you have R2, you have R3, and then you have R4. So what happens is that the Wheastone Bridge is used to find the value of an unknown resistance through the balancing of the galvanometer. Now, what do we mean by the balancing of the galvanometer? This is what happens. The 4 resistors, let's say that resistor R1 is a resistor that is unknown, and resistor R2 is known, resistor R3 is also known, and then resistor R4. So what happens here is that resistor R2 and R3 could be standard resistors, while resistor 4 could be a variable resistor. So what happens is that the value of resistor 1, which is unknown, the value of resistor 2, which is known, the value of resistor 3, which is also known. So what happens here is that this variable resistor will be varied, until a point will come where the galvanometer will have no deflection. The galvanometer start from 0, and then from 0 to this side you have plus 30, and then from 0 to the left you have minus 30. So a point will come where the galvanometer will not deflect. If you change the resistor and switch on the circuit, as you can see, the galvanometer will just be pointing at 0. At this point, we say that the galvanometer is balanced. We call it the balance point of the galvanometer. At this balance point, what do you expect? At the balance point, it is said that the potential at B, as you can see in the diagram, the potential at B and D are the same. At this point, when the galvanometer has no deflection, which is called the 0 point of the galvanometer or the balance point of the galvanometer, this is the equation that we have. So in this regard, we now write that the potential at the arm AB will be equals to the potential at the arm AD. Also, the potential difference at the arm BC will be equals to the potential at the arm CD. Now, you know that from Ohm's law, V is equals to what? IR. So we are going to customize this in such a way that this is what you are going to have. So for V potential at AB, it is given to be at AB. What you have I1 R1, I1 R1. So potential at AD is given to be potential at AD is given to be I2 R3. This is I1 R1, I2 I3. This is the potential at, let me correct that quickly. This is I1 R1, this is R3. So the potential difference at BC, that is BC, is given to be I2 R2, and so the potential difference at CD is gonna be that is the arm CD. You're gonna have I2 and R4. So when you look at all of this, you discover that we said that the potential at AB is equals to VD, and potential at BC equals to CD. So these are the values. So we are now going to form an equation with this. So we now write that your I1 R1 is equals to your I2 R2, your I2 I3. You call this equation A. So we have the second equation as I1 R2 is equals to I2 and R4. We call this equation B. Now, what we're going to do here is that we are going to divide equation A by equation B. So we divide equation A by equation B. If you do that correctly, we are going to be having I1 R1 is equals to I2, R3. You divide both sides by equation B again. I1, R2 is equals to I2 and R4. So that this will cancel out this, and this will cancel out this, and so you are left with R1 over R2 equals to R3 over R4. So you have R1 over R2 is equals to R3 all over R4. Call this your equation number what? We have equation this is equation AB, and call this your equation C. Call that equation number C. So equation number C is the Wheastone Bridge equation. At this point, you now make your R1 the subject formula, which was declared as the resistance whose value is not known. Now, having understood the working principle of the Wheastone Bridge, let us look at the Metre Bridge. The Metre Bridge is defined as the practical arrangement of the Wheastone Bridge. The Metre Bridge works with the principle of Wheastone Bridge to measure an unknown resistance. This is what the Metre Bridge is. And so beside you is the picture of the Metre Bridge. Now, learning is always from known to unknown. So because you have mastered the theory on the Wheastone Bridge now, I'm not going to take us too far with the Metre Bridge. But if you can see the Metre Bridge also works with the same principle like the Wheastone Bridge, so that the galvanometer also reaches a balance point where it has no deflection, where it points straight at zero. So if you can look at the diagram very well, we have resistance R1, we have resistance R2, and then down here we have L1 and then also L2. Good. So you can see the point where the jockey P is pointing. The jockey P is pointing. At that point, the galvanometer is said to be at its balance point. That is the point where you take your reading. From A to O, it is your L1, you take the reading. From O to B, it is your L2. From P to B, it is your L2, you take your reading. Now, relating this equation for the Wheastone Bridge to that of the Metre Bridge, we have R1 all over R2. Instead of writing R3, we now write L1. We now write L1 all over L2. So this is the equation for the working principle of the Metre Bridge, where R1 is the resistance whose value is not known. R1 is the resistance whose value that you are looking for. Now, in this experiment that we are doing, R1 may be given to you, and you see that the right hand of the Metre Bridge, where you have R2, you are going to replace that standard resistor with a length of a resistance wire. Now, because you are doing this, you have to remember the factors that are affecting the resistance of a wire. You know, we have the length of the wire, the cross-sectional area of the wire, we have the temperature and the likes like that, and also the resistivity. So you have to revise in all of this area, knowing that the length of the wire is directly proportional to the resistance of the wire. So these are the basics that you need to know. So the next video that you are going to see is the video where I practically connect the Wheastone Bridge and I have demonstrated its balance points, and also the Metre Bridge, and I have demonstrated its balance points. For the experiments that we have at hand, what we are going to do is as simple as ABCD. So let me quickly draw this. This is your Metre Bridge, and this is one of the arm of the Metre Bridge, and this is the middle. The diagram you are seeing beside me, that is what I'm trying to explain right now. Good. So this is my S1, and this is my S2, and this is my S3. So one arm of the galvanometer, so this is where you're going to put this is where you're going to connect the resistance, or the resistor whose value is known. And one arm of the galvanometer will be connected here, and this is your galvanometer G. And the other leg will be connected down here as with the jockey. So the circuit will protrude, will come down to this side where you have a cell or battery connected, and also a key connected. Good. So this is how the connection is going to be. So this left arm, this gap that is at the left arm, this gap that is here, this is where you are going to be connecting that wire. So you'll be connecting 100 centimeter of the wire. You will drag this jockey until when you see a balance point at the galvanometer here, then you take your reading. So from this point to this point will be your L1, and from this point to this point will be your L2. So when you are done with the length of 100 centimeter, you are going to put another length again, let's say 80 centimeter. And these are for different wires. It could be that this is let's say wire Q, which is the Constantine wire, and you'll be changing the length, varying the length until you run the experiment to the end. When you are done, you put another length again, maybe 70, in that order. When you are done with everything, you replace another wire, maybe let's say copper wire, let's say wire P, the copper wire. You repeat the process. So this particular place, this is where our R2 standard resistor was. But we have removed this standard resistor and have replaced it with the length of the wire, which is also a resistor in nature. So this is all about the experiment. So the next video you are going to see is just a practical connection of this diagram and what you need to know about it. Now, before I end this video, these are some of the information that you need again. The precautions in this experiment are very, very important. And one of the precautions is that while trying to find the balance point along this Metre Bridge here, don't drag the jockey. Just dab it. Just a dab. You dab it or you tap it. You tap it, you see. If it goes left, you tap it again. Keep tapping. If you tap this side, you may see that it goes left. If you tap on this side, you see that it goes right. So keep tapping until when you tap and the galvanometer is just pointing at 0. That is when you take your reading. Now, the next thing is that precaution. So this one I just said is a practical precaution. So you state as follows: I ensured the jockey was not dragged. I ensured that the jockey was not dragged on the wire. When you do that, you're going to have wrong values. Number 2 precaution: the examiners, the authors of several books advise that we take the reading of L1 and L2 twice so that we find the average. Or you also, that is another precaution. So I took average reading of L1 and L2. That is another precaution. Another precaution is that you are reading the meter rule, so you have to avoid error due to parallax. So you will state as follows: I avoided error due to parallax when taking reading on the meter rule. The next thing you have to do is how to tackle the questions in the BI and the BII parts. Because you are dealing with the potentiometer, with the meter bridge, this guy, there are 3 of them in line. The potentiometer, the Wheastone Bridge, the meter bridge, they have their separate calculations. For the potentiometer, it's a variable resistor. You all know that. They may ask you to calculate or to do some calculations under galvanometer conversion. So these are all the areas that you need to lay much emphasis on. I take that again. For the BII and for the BI and the BII part of this experiment, you need to master everything about potentiometer, everything about the Wheastone Bridge, everything about the meter bridge, and if possible, the rheostats. Their theory, their calculations, their working principle. And it will shock you to know that I have done a lot of videos on the Wheastone Bridge potentiometer. Just click in the description box below and you will find the link to all these videos. So these are the areas that you have to prepare, so that when you see a calculative question there, you can know how to go about it. To this, we have come to the end of this experiment. I wish you guys success in your exams, and don't forget to subscribe, like, comment, and share this video to those that need it. I wish you guys straight A's in your exam, distinctions all through. Thank you and God bless you. Bye-bye.